Everyone, and welcome to this video. In this video we are going to talk about how to calculate molar masses. Okay, we have three different type of questions which we will solve today. Like one which is like very common, in which you first just have a formula, one in which there is a dot involved, and one there is a bracket involved. So let's see how we can do it. To solve these questions you need to know the relative atomic masses, and these relative atomic masses you can get from the product table. So you need a product table to solve, to calculate the masses. Now in a product table, I want to explain some facts here. You will have to see which one is atomic number and which one is atomic mass. So in all the product tables, you will find a key. Somewhere on the product table, you will find a key like this. It will tell you like what information this product table is giving you. Like here, it's given atomic number. Like on the top you have the atomic number, then you have the symbol, then you have the name, and you have the atomic weight, and you have the electrons per shell, like how many electrons are present in each of the shell. So you don't have to get confused. Like I have seen students getting confused like which one is atomic number and which one is atomic mass, because it's not the same in all product tables. In some cases you will see the atomic mass is up and atomic number is down. So you can use this information from the key, like this is atomic weight and we need this value to solve the molar mass questions. Okay, let us try now. We have H2SO4. So this is telling me that this molecule has 2 hydrogens, 1 sulfur and 4 oxygens. So how can I find the mass? So I have 2 hydrogens, so 2 into the mass of hydrogen, which I will get from the product table, plus 1 sulfur, so 1 into the mass which is present in the product table, plus 4 oxygens, so 4 into 16 the mass of oxygen which is present in the product table. You will solve it, you will see you will get around 98.09, and the unit is very important, grams per mole. This unit is telling me that in 1 mole we have 98.09 grams of sulfuric acid. You can solve all the questions which are in this format, the formulas, with this method. Like you have any other formula like HCl, HNO3, you just use the product table and you can solve them. Some questions you will see that there is like dot involved. This is basically what? This is water of crystallization. To make crystal of this copper sulfate, we have 5 molecules of water inside. So when we want to find the mass, how we will do it? You need again the product table for the masses. Okay, let's do it. You have 1 copper, so 1 into 63.55. I want to explain another fact here. I have seen students getting confused with this fact. What is the difference here? This is CO and this is CO. What's the difference? The symbol. Very important here. This CO is basically 2 elements, carbon and oxygen. It is a compound. But if you look at this CO, this is 1. Then when the second alphabet is small, it is like continuing the first one. So this is cobalt. This is an element. This is not a compound. So you have to be very careful in this. This is U. This is not a separate element. This is basically one symbol. This is Cu. And this is capital. This is capital. So they are different. 1 into 63.55 plus how many sulfurs are there? 1. So mass of sulfur is 32.07 plus 4 oxygens. So 4 into 16.00. Now there is a dot. There is a dot here, but when you are doing the mass, you will take it as a plus. Plus 5 into the mass of water, which is how much? 2 into 1.01 the mass of hydrogen plus 16. So this 5 will be multiplied with this water, but then it will be added with CuSO4. And what will be the mass you will get? You will get around 249.72 grams per mole. Third type of question which is very common in this mass calculation is zinc. Like the question in which there is a bracket involved, like Z and OH twice. How to do it? the masses you will get from the product table, the mass of zinc is 65.38. So 1 zinc is there. So 1 times 65.38 plus. Now this 2 is for oxygen also for hydrogen. So we'll use it for both. So 2 into 16, the mass of oxygen, always use 2 digits after the point so that you don't have any problem in significant figures, plus 2 into 1.01. So you will get around how much? 99.424, or 42 because 2 digits, so grams per mole. When you are using the mass from the product table, you will see different uh, aspects, like there are 4 digits after the point, 5 digits after the point. It is good to take 2 digits after the point always, like 1.01 for hydrogen. No need for 1.0001, only 1.01 is okay. Thank you guys, thank you so much for your time. I hope you understand the lecture.